All right, guys, this is the last section. We made it. Oh, we're so close. We're getting there. We've got still the exams and a test and all that stuff, but this is the last lesson. Okay, so what we're doing in this section is we're bringing together everything that we've done so far, pretty much in Algebra 1. We're going to be comparing linear, quadratic, and exponential functions. So it's going to be a little bit of everything. And you're going to be looking at tables, you're going to be looking at graphs, and you're going to be writing equations. So I'm going to try to keep this short and sweet, but we'll see how this goes. So let's review for a second. So this is a linear equation. This would be a line. M is your slope. Remember, to find your M, it's how much do you rise over how much do you run. So like this one would have a slope of 2. And then y-intercept is where your graph is crossing the y-axis. In this case, it would be 1. So the equation would be y equals 2x plus 1. So you're going to see those. The other thing you're going to see are exponentials. Your A is your starting point, and it's starting at 1. B is what is the pattern. So like, let's see, we've got a point here, a point here, a point here, and it's a pattern based off of the y values. So this has a y value of 1, a y value of 2, a y value of 4. So what's happening to go from 1 to 2 to 4 is you are multiplying by 2 each time. And the equation for an exponential was y equals a times b to the x. So we would write this as y equals 1 times 2 to the x. So you're going to see those exponentials pop back up. And writing equations. So we've done these all before. This most recently, this you've been doing probably since like 6th grade. But I want to just kind of review again what to look for in tables to determine whether it's linear or exponential. Linear, from a table, you know that it's linear when the pattern of the y values uses addition or subtraction. So like here, to go from -1 to 1, you add 2. From 1 to 3, you add 2. 3 to 5, you add 2. So this would have a pattern of 2. Because you're adding 2 every time, that would be your slope. Actually 2, and then it'd be rise over run, which these are going up by 1. And then your y-intercept is always the y value when x equals 0. So the y-intercept would be 3. So if I needed to write this in slope-intercept form, I would write it as y equals 2x plus 3. So there's linear. Quick little review on that. For exponential, we know that we have an exponential function with a table when, so exponential is when the pattern, again, of the y values, it's all about the y values, uses multiplication, not division. If you end up finding that it uses division, remember you put a 1 over top of it, and then that's what technically it multiplies by. So this one goes from 1 to 2, 2 to 4, 4 to 8, so you're timesing by 2 each time. So that would mean, so when you're writing these exponential equations, you have to know your A and your B. A is always the starting value, so 1. B is the pattern, so 2. So you would write this as y equals 1 times 2 to the x. So that's how you know when it's exponential. Quadratic is a little weird. And honestly today, and this is probably not the mathy way to tell you, but your problems today or your tables today are either going to be linear, exponential, so pattern using plus or minus, pattern using multiplication, or they're going to be quadratic. Quadratic tables are kind of weird. Not gonna lie, like this is an example. So what you do is for quadratics and how they work, you can't really write an equation from a table for them, so that's kind of a good thing for you, is you find your pattern of the y's, then find the pattern of the pattern. I know that sounds weird. So I'm going to show you what I mean here. And they kind of have it written out here, but to go from 3 to 9, you go up 6. To go from 9 to 19, you go up 10. 19 to 33, you go up 14. And then from 33 to 51, you go up 18. To go from 6 to 10, you go up 4. 10 to 14, up 4. 14 to 18, up 4. So because the second pattern is all the same, that makes it a quadratic. So that's just like an FYI. It's going to be the one where it looks like there's no pattern, but really there is like a pattern of the pattern. I know that sounds weird. So like for instance, these are some problems that you're going to be doing today. Let's take a look at tables and figure out they're going to be one or the other. Linear, which means they use plus or minus. Exponential, which means it uses multiplication. And quadratic is where it's neither one of those, but it uses, you can find the pattern of the pattern. So if we check this one, to go from -2 to -5, you go down 3. From -5 to -14, you go down 9. To go from -14 to -29, you go down 15. From -29 to -50, you go down 21. And then if you check here, from -3 to -6, I'm sorry, from -3 to -9 is a -6. -9 to -15, again -6. -15 to -21, again a -6. So see how the pattern of the pattern ends up working out, or the pattern of the difference, I guess is probably what it's called. So this would be an example of a quadratic. It's going to be one or the other. It's going to be one of the three. So if it doesn't follow in either one of those, I guess the process of elimination. For number 5, to go from 4 to 12, you would multiply by 3. 12 to 36, again, multiply by 3 times 3 times 3. So that means that this is exponential. And then to go from 50 to 42, you go down 8. 42 to 34, down 8. But keep going. This is going to be linear. So that's part of what you're going to be doing today. The other thing is you're going to be looking at graphs, which should probably be pretty easy to figure out which graph represents what. Is it either a linear graph, so is it a line? Is it quadratic, which means it's a parabola? Or is it exponential, which means that it's slowly increasing or decreasing, it's curved. And then once you figure out which one it is, then you're going to write the equation. So there is a couple of pieces of information that you need in order to write the equations of these. So for number 7, this is clearly a line, so this is linear. In order to write an equation of a line, it's going to be y equals mx plus b. M is your slope, that's your rise over run. So I'm going to go from here to here. I go up 2, right 1, 2 over 1 is 2. And then y-intercept is where it's crossing the y-axis, and that's at 3, so plus 3. That's it. For number 8, this is slowly, or it's increasing faster than a line, so this is going to be exponential. Exponential graphs, remember they have those asymptotes and stuff, and they get really close to the x-axis but never touch it. Exponential equations are y equals a times b to the x. A is going to be where it starts, so your starting value, which is the same thing as like your y-intercept, so it's crossing the y-axis at 4. B is the pattern of the y values. To go from 1 to 2, 2 to 4, you're multiplying by 2 each time. And there's your exponential equation. And then the last one, this is a parabola, so this is a quadratic. So in order to write a quadratic equation, you do y equals x minus h squared plus k. That's the technical formula for it, or the equation for it. Basically, we're going to check and see based off of the parent function, how does it move? So the parent function is always at 0, 0. It moves down 5. So if we don't even look at this, let's just say it moves down 5. The parent function is always y equals x squared. That's what we do. So if it moves down 5, we would write that as y equals x squared. Down 5 would have minus 5 outside of the parentheses. So that is it. That is the last of the information that you need from me. I'm not sure if I'm even going to have to make another video. This will be kind of nice, maybe for all of us. So there will be a test over this week, this Thursday, and then we will have exam review after that, and I can do some review sessions if you need them. I'll be putting some Google Forms out to ask about how you want to do those. But good luck today, and I'll be touching base soon.